In this video, we are going to discuss graphing quadratic functions that are given to us in vertex form. You're going to take your notes in your booklet on page 3. So let's start by just kind of discussing what vertex form means, and that's this general format here, f of x equals a times x minus h squared plus k. Now, in the last couple of days, we've been discussing what a, h, and k do as far as transformations in relation to your parent function. Now we're going to put them all together in one. Let's start by just remembering what the x squared tells us. It tells us that it is a quadratic function and the graph is a parabola. So that's important. When we see this squared here, we know that we're going to get a parabola shape. Now our a, h, and k each have a different effect on our graph. The value of a, it depends on our sign and how big it is. If it's negative, that means that the graph is going to be flipped, or reflected would be a more precise way of saying it. If it's greater than 1, then it's going to be stretched, which actually means it's going to be skinnier than your parent function. And if it's less than 1, it's going to be compressed, which means it's going to be fatter than your parent function. The value of h determines the horizontal translation, so the movement left and right. And it also tells us your x-coordinate of your vertex. So horizontal translation moves you left to right. And again, that's going to help us determine the x-coordinate of our vertex. And then our third, here is our vertical translation, which gives us our y-coordinate of our vertex. So again, our vertical translation is going to go up and down, and that is going to give us the y-coordinate of our vertex. Now we're going to look at an example where we use these values to graph a quadratic function. So our directions say to determine the values of a, h, and k and describe their effect on the graph of the parent function, which is f of x equals x squared, and then graph. So let's start by defining or deciding what our a, our h, and our k are. So if you look at your general form, it's a times x minus h squared plus k. So the a is negative 1, right there. The h is 2. Be careful, the minus is already in there. So you're not going to include, it's not going to be negative 2, it's going to be 2. X minus h, x minus 2. The h is 2, and the k is 1. So h is 2 and the k is 1. Now remember what the a is going to do is it's going to flip it or reflect it. So that means it's going to open down. The h is going to move us 2 to the right. And the k is going to move us up 1. The hk also gives us our vertex, h comma k. To graph, we're going to do a table of values. And we're going to put the 2 comma 1 right in the middle because that's our vertex. That look like a negative 2. 2 comma 1. Now we remember we want to do 1 on either side, so I'm going to or do 2 on either side. So I'm going to subtract 1 again, and then add 1 again. I'm going to choose to plug in the 0 and the 1 just because they're smaller. So I'm going to have negative 0 minus 2 squared plus 1, which is negative 2 squared plus 1, which is negative 4 plus 1, which is negative 3. And I'm going to plug in the 1. So negative 1 minus 2 squared plus 1 which equals negative 1 squared, which is negative 1. Negative 1 squared is a positive 1, plus 1, which is 0. Using my symmetry, I know 3 is also going to be 0, and 4 is going to be negative 3. And then I'm going to plot my points. So my table of values got a little messy there. Again, remember, around your vertex, the y values will be the same. So 0, comma, negative 3, 1, comma, 0, 2, comma, 1, 3, comma, 0, and 4, comma, negative 3. So it is opening down just like we said, connecting that nice smooth U shape. So what we just did was we used our values for H, A, and K, found our vertex, did our table of values, and graphed our quadratic function.